I'm Patrick Bailey with IQlist.com. Today is February 10th, 2021, and in this video I'll be going over a PVC pipe mount I put together here just recently. Okay, first the short story. So I'm working in my basement right now, putting together some shelves for some storage. A lot of Christmas stuff I'm storing down there right now. And as part of this, I've been trying to figure out something to store a bunch of wreaths my mother-in-law has. And so I was thinking about making something kind of like a drying rack. So something kind of like some thin, PVC pipes coming out that I can put a little lightweight board on, a very thin board. Then I can put the wreaths on there. But I can do several. So I came with this idea: is just to 3D print something that I can mount to a 2x4 and have it at a little bit of an angle, and then I can just put a 1-inch PVC pipe in there, and then do two of them, and then I can span it with a board. So that was my basic idea. And I haven't had time to actually put together to test the theory out, but I have gotten this done. So we'll see how it goes. Maybe I'll show some pictures of that when I actually get to that point, because I haven't actually put it up yet. But I think it'll work just fine. But with that, let me go over a few things. So I've already posted this on Prusa Printers, so you can go to Prusa Printers and download it if you want. And it happens to be 56008. And I've also put it out as a gist over on GitHub. So I'll put a link in there too, because I did this on OpenScad. So you can go get the OpenScad and you can go look at it. Now with this, I'm debating whether it was a good idea to do it in OpenScad, because I thought it was going to be simpler than I thought it was. It turned out to be more complex, but I did get the job done. So here's the basic idea. So always, I think I've said a few times, draw some ideas in a booklet, keep track of them, because I think it helps you with your timing. When you're trying to design something, it can save you a lot of time, kind of give you an idea. So in this case, I was actually trying to plan out how I do it in OpenScad. So you can see here, what I was talking about was like, hey, let's do a cylinder at an angle, and then remove a cylinder from inside. But then also, maybe it'll probably show up better here. Like here's a cylinder, but then it goes at an angle here. I thought, hey, I need some reinforcement. Let me put like a cone shaped in there, and I'll have that cone shape go through, and then I'll add the backing. I'll have the cone shape go through, and then I'll come back and mathematically subtract the parts. And so that's what I did, but it proved to be a little more difficult than I thought, but I did get it working. So I will go over the OpenScad at the end here, so for those who are interested and want to see how it was all put together. But the OpenScad is adjustable, so if you have a different PVC pipe, you could change it. So it should be pretty easy to do that in theory. But with that, let me go over the numbers. So here are the numbers. So this took 3 hours and 30 minutes to print. It took 3.2 cents worth of electricity, and it weighs 0.028 kilograms. And at $20 per kilogram, it comes up to 56 cents worth of material. So all in all, it cost 60 cents to print this. So not a bad deal. And I think it's going to work pretty well in my basement. So boom, pretty simple. I like it. So with that, let me go show off what I can in the basement, even though I don't have the shelves up. I do have an example screwed into the wall, screwed into a 2x4, so I can kind of show it off, the idea. So I'll go show that off, and then after that, we'll come back and show how to recreate it in OpenScad. Okay, so like I said, I haven't enough time to build the shelves I want to build yet, but here's the idea. So I got this. The idea is I want to kind of screw these into a 2x4, and then we just can take this and, it's nice and tight and firm, and so I'm going to have two of these that I can build. I can put I don't have a good example here, but I have two of these, and I'll put something like this. The other one will hold it up. I'm not going to do 2x4, something much thinner. Then I can put these wreaths on, so it's more like a drying rack. But there you go, the idea. Put it up there, put a couple of screws in there, and you're good to go. Plus, you can do this. Makes noises. Okay, so here is my current OpenScad file. So we'll just kind of go over it a little bit here. Now, this is one of those things, if I recall an old story, Osloy, who turned me on to OpenScad, and he sent me something one time, and it was like really neat. It did a job I wanted to do, with something with putting feet on my 3D printer. But some of the variables weren't perfectly adjustable. So you could change the parameters, and the design would blow up, because it gets really hard, and I'll show how it gets really hard in this example. I'd have to do a lot more coding to make it universal, where you could make one change and it would adjust everything correctly. Versus like what I have here, you can kind of tweak a little bit, but once you go too far, you kind of get out of the parameters of my design, where I did it simply, and it kind of blows up. But I could go back and redo the code and make it more complex to adjust for those things, but that takes time. So as an example here, right here is the inner diameter here, 33.7 millimeters. But if I change that, I can go here and make it 10, boom, and we see that goes in here. But now you see that cone. So here's this cone that comes in here, and I designed it to cut it off in the middle, but now it's poking through. So I'd have to make this design a little bit different to account for that. But I could go down here, and I think I could change the cone size, and the cone would shrink, and there you go. But now I just move the cone. So you see how it starts cascading the error. So let me go back here. But let's say you were like this, and so it looks fine. And let's say you want to go, 3/4 that. So I say 3/4 multiply, so 3/4 thing. And I'd say 3 divided by 4, multiply that. So I do a smaller pipe as an example. And see, that kind of works. But you can see this is still poking out a little bit. And I'd have to, maybe I could adjust this. Yeah, so drop that down to 50, and that kind of works. So some things you can adjust, but I could have made this, for example, this cone popping over the top. I could have had another feature which cuts that top off, which I didn't do because I just wanted to get the job done. But we could take it as is. Let's say you want to do 0 degrees. That should, in theory, probably work. Yeah, there you go, 0 degrees. If you wanted 0 degrees, that seems to work pretty fine. Okay, just to show you the complexity of doing things in OpenScad, it's hard to come up with it. It takes more time to have a full design where you can adjust 3 or 4 parameters and not have it blow up on you. It's possible, but it takes more time. Okay, so with that, let me walk through the idea I had here. Okay, one thing I had up here is there's an Fn. If those people who aren't familiar, Fn equals 200. I put 200. You can think of that as the fineness. I don't have it up right now, but just to remind people, if you're using OpenScad, it's a good idea to open up their cheat sheet. So OpenScad/cheat sheet, OpenScad.com or org/cheat sheet should give you the cheat sheet. This Fn 200, that's how fine you want to do it. So if I had something like do I have a cylinder on this one? Or did I not? I did not do a cylinder. Oh. Let me just do a circle. So if I did a circle of 40 as an example, boom, so I get the circle. Now if I drop that fineness down to 10, I got 10 sides. So that's but it takes longer to render. So at some point, you might want to leave this low, like a 10 or 20, if you want to render things quickly. Then when you're done and you're ready to do your model, pump it up to 200, just so you can get that more fine result. And also, per object, you can actually adjust it, which I had to adjust on one thing here. Okay, so with that, let me get started on a few things. So first, we'll start with the cylinder coming up there. So I'm going to do, just to color code these things, I'm going to say color red. So everything inside of here is red. And then we'll do a circle, and we'll say D equals inner diameter. Well, let's do the outer diameter first. Sorry, outer diameter. Well, that's a variable now. We haven't defined it yet. And we'll come up here and we'll start defining some of these. And so we'll say outer diameter. And I'll just go with the numbers I'm using right now, which is 44 millimeters. Oh, not 2 equals. And boom, we already have an error. So what did I do? Oh, did not spell circle right. It's always a good idea to write a little bit of code, test it, make a change, test it, make a change, test it. That way it's easier to find your errors. Okay, so we got our circle. The next thing I want to do is we do want to do a linear extrude. Because right now it's just 2-dimensional. And so I said, in this case, I used a variable 3 times the whole depth is what I decided to do. But you could make it just a number. And down here, so I need to make my hole depth. And my hole depth, I said, equals 30. And that's how deep this hole is to go into here. So we run that. Boom. Oh, sorry, I did need to do that. Boom, boom. Boom, there we go. So there's that. Now the next thing we got to do is we need to, what do I do? Color red. There we go. There we go. Now I got a color. Now the next thing I do is I need to put that inner cylinder that's going to subtract it. So I'll come down here and we'll say circle D equals inner diameter. Boom, boom. And I'll come up here and I'll say inner diameter equals, I think I had 33.7. 33.7. Boom. And I need to do linear extrude of this. Boom, boom, boom. And now what I'm going to do is I'm going to say I have the hole depth. So I'll say hole depth. That's how long I want to make it. But I'm going to add 1 to it just so I can use that to pull things around. Well, let me make it 2. No, make it 1. 1's fine because that means I'll just go above. No, stop that. Okay, so now if I run it, it did make it, but I can't see it because it's hidden inside of there. So now what I need to do is I need to move that. So I'll do a translate, boom, which will move that guy. And boom. Okay, and then we'll say, so this is X, Y, and Z. And so X, we're not going to move it anywhere. Y, we're not going to move it anywhere. And Z, what we want to do is we need to move it 2 times the hole depth plus 1. Because here we're going 3 tall compared to how I made that hole depth. So here I'm going 2 tall, plus I'm adding 1 little more to kind of creep over the top. So now we can see how it's creeping over the top. But then now we need to subtract them. So we'll make a difference. Difference. Boom, 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 boom. Boom, boom, boom. And there we go. We got this shape. Now you will notice this is much longer than I made because what my intention was to make this too long and then pull it back and angle it and then slice it out. So that's one reason I did this. Okay, so now the next thing I'm going to do is need to rotate it. So we'll say rotate, and we'll rotate this whole thing in place. Boom. Okay, and this is where it gets fun. So we can say angle, so how much we're going to rotate it. And then you can rotate this in different dimensions. You can do, X, Y, or Z. So we don't want to do it in X, so we put a 0. And we do want to do it in Y. In this case, you put a 1 or a -1. Maybe you can do half variables. I don't know. And Z, we don't need to move it. So then come up here, we need to actually put our angle in. So I'll say angle. That way it's easier to change. Angle's 5. Boom. We see that we rotated the whole thing. Now if I did a 1, it would just go the other way. Boom. Now, can I do... Never tried it. -1/2. Is it going to just do a little bit? Or it doesn't matter? Okay, I guess as long as there's a negative or positive value, I guess that's how it works. Just never thought about that. Okay, now we need to move this. So I need to move it down. Translate. Boom, boom, boom. Okay, and we translate it 0, 0. I need to move it down. I'm going to move it -3 times the whole depth divided by 2. That's just the number I came up with that made me happy. So now that pulls that down, makes me happy. Okay, so now that part is done except for the slicing of it. So the next thing I want to do is we want to create the cone. So I'll go down here. Boom, boom, boom. And the cone is just going to be simple cone. So we'll say color. We'll separate it in different colors. We'll call it blue. And then I think, did I write this one? Okay, we use the cylinder, boom, cone, bottom. That's how big the bottom of the cone is. And then how high it's gonna, let's see. That's the bottom. Let me bring up the cheat sheet because I think I'm misremembering. Let me check. So there you go. OpenScad.org cheat sheet. Oh. Cylinder. Okay, and here we have the height, the bottom radius, and the top radius. Okay, so I kind of messed that up. Shouldn't actually be cone bottom. It should be cone height. What are you gonna do? Okay, so cone height, I based that off. It's not really the radius. Cone height equals 60, I believe. Yeah, look, fixing my own code already, right? Cone height equals 60. And then we have bottom radius and top radius, and whether it's centered. Okay, so we basically say, So we say for the bottom radius, I'm saying 3/4 times the outer diameter. I guess is something I decided to do. Who knows why? And a 0 for the top. So 0 is how, so it's going to make a cone shape. Big on the bottom, nothing on the top. And we should get our cone there. And you can see it's flat right there, which is fine, but you can see it's bisecting this just fine, like that. And we need to eventually cut that out. So that's going to be a join. Okay, now what do we do? Now it gets fun. Where's our orange? Purple, orange. Oh yeah. Now we get to the orange part. I'm probably not going to be able to complete all of this because it gets crazy. Okay, so now we do the bottom part. I probably should do like a live stream of all this because it gets really fun. Okay, so we're going to have a circle that I said diameter equals, I just called it 2x4. 2x4 diameter, which is a real weird way of saying that. Okay. And so we'll say for the 2x4 attachment part, there's my diameter is 35 and our thickness is 10. So we come down here and make a circle. And yeah. So we make a circle, which would show up down there, but I can't actually see it because it's too small. And then we're going to translate it. So translate it. Translate. And we'll move it 2x4 diameter and 0. Boom. Oh, and how about I enclose all that? Boom. So that one's over there. And then we'll make a sister to it. So we'll do the same thing, but with a negative diameter, if I recall. Let's see. Boom. We got that guy. And then we can use this cool tool called hull, which is going to attach both of them. So you can say everything in there, we're going to make a hull. And if I do that, boom. And see, now they're attached. So you got this little nice big oval shape. And then I need to do a linear extrude. Linear extrude. Boom, boom, boom. And we're going to do that 2 times 4. Well, that's a variable. 2x4 thickness. Boom. So there we go. We got the basic shapes. Now comes all the subtraction part, which is fun. It's just really fun. So that, I'm going to have to do copy and paste, otherwise it's going to get a little crazy. So the first thing we can do is for this part. So for the 2x4 part. So I can comment out this top section so it'll go away. So we comment that guy out. Now we've got that. So we're going to come down here and we're going to make some more shapes. So I'll cut and paste these. So these are the screw holes. So here I'm basically taking a cylinder. Here's a cool thing. I'm taking a cylinder of a certain size because this is where my screws are going to go in. But what I want to do is I kind of want to make it a hexagon. So to do that, you can actually specify here at the end of the cylinder, I can specify the Fn equals 6, which will make it a hexagon. So in here, I'm making 2 hexagons, a small one and a bigger one, and one's going to go up the whole distance and one's going to go up a little distance. That's why I have kind of an inset. And so then I will close this whole thing off, move this over, and on this I'll make a difference. Because what I'm going to say is, hey, take this guy and then subtract these screw holes from it. And boom, now we got those. And so those are cylinders. These inside are cylinders, but they're 6-sided cylinders, which makes a hexagon. And one goes all the way through and is the smaller one, and one goes part way through. That way I can kind of use my my wood screws and they'll go in. So there's that. Now, so if I bring everything else back, boom. So now I got to start subtracting all the rest of it. And that's where it gets complex. So, I don't want to make this video too long and belabor it. So really, the easy part, if you look through the code, I do just cut off, I make a big square and cut off everything in the bottom. So that guy gets cut off. And then I also make some polygons to cut off the side here, because you can see in the end product, there's a little angle here. So that angles up. So I have a little polygon on both sides that has a linear extrude and cuts the whole thing out. And then the fun part is this cone is inside here still. And so basically I have to recreate that cylinder in the middle and subtract it again. Now there's other ways to do it. I could have waited to subtract it to the very end. But you can see how it starts getting complex. So I got it done and somewhat adjustable, and I like it. But this seems like something, either I need to go to the next level and make it better, code it better, so it's much easier to adjust it based on whatever pipe size you want, or it's probably an easier thing to do in Fusion 360. And maybe I'll come back and review that. It'd be nice to, if I get some time, to go do a live stream and really go through maybe redesigning both of them, going through the full gambit, showing how to do this, and then showing how it's probably a lot easier to do in Fusion 360 for this particular thing, which I didn't think would be this hard. But also it's interesting. It's interesting to programmatically do this and add and subtract things. So, okay, that's as far as I can get kind of my time allotted, so I don't want this to go to too long. But anyway, hope you found that interesting, and if you need to stick a PVC pipe on your wall, there you go. I like these practical prints. Better life through 3D printing. Now, as you see the images scroll by here, you should see a giant plague doctor I made. It was my first giant print that I did of a statue I had to cut in 2 parts, and I think it turned out pretty well. In fact, my son has already claimed it. Now, my next video is going to be about 3D printing a catapult. So I found a good catapult out there I like right now, and so I'm going to go print it, take some numbers on that, and show it off. I think it's pretty good, and hopefully, at some point, I think I want to do a redesign of it. I think it's good, but I think it can be done better.